Imagine two colossal black holes drifting toward each other in the depths of cosmic darkness, moving at unimaginable speeds. And then impact. A collision so intense it ripples through spacetime itself, revealing the presence of a hidden giant. But this isn't just any black hole merger, this is the beginning of one of the strangest black hole systems ever uncovered. Chinese astronomers have detected a hidden supermassive black hole lurking in the background of an unusual gravitational wave event. In what may be an unprecedented discovery, they've identified a possible triple black hole system. After spotting the concealed supermassive black hole behind a peculiar gravitational wave signal first recorded 6 years ago, researchers were able to reconstruct the trio. In 2019, the Laser Interferometer Gravitational Wave Observatory, LIGO, recorded a series of faint ripples in the fabric of space-time gravitational waves. These waves appeared to originate from the merger of two distant black holes, located between 544 and 912 million light-years from Earth. The cosmic collision, named G190,814, drew particular attention due to the unusual mass of the merging singularities, estimated at 23 and 2.6 solar masses, respectively. Typically, black holes that merge have similar masses, as this balance creates the gravitational friction needed to bring them together. But according to a 2020 study on G190,814, this event represented the most extreme mass ratio ever recorded in gravitational wave data. Scientists were especially intrigued by the smaller object just massive enough to qualify as a black hole. According to Live Science, a new study published on July 21 in the Astrophysical journal suggests that this asymmetric merger may have been influenced by a third, hidden object. This mysterious mass likely provided the gravitational push needed for two black holes with such different masses to collide and form a single singularity. Using simulations, the research team predicted how this interaction would affect the gravitational waves produced by the merger. They identified a unique signal like a cosmic fingerprint linked to the hidden mass. Upon reanalyzing LIGO's original data, they confirmed that this fingerprint signal was indeed present. When Biao Han, an astronomer at the Chinese Academy of Sciences and one of the study's authors, stated, "This is the first international discovery of clear evidence for a third compact object in a binary black hole merger event. It suggests that the binary black holes in GW190,814 may not have formed in isolation, but as part of a more complex gravitational system." Based on simulations, the team believes the most likely identity of the hidden compact object is a supermassive black hole. While its exact size remains unknown, the lower threshold for supermassive black holes is around 100,000 times the mass of our Sun, meaning this object must be at least that massive. It would be vastly larger than the two merging black holes initially identified. It's possible that the smaller pair of black holes were part of a binary system orbiting the supermassive black hole, similar to how Earth and the Moon orbit each other while jointly circling the Sun. This marks the first time such an arrangement has been observed in a black hole system. The newly formed black hole from the merger may continue orbiting its supermassive companion for billions of years before eventually being consumed. These findings not only offer critical insights into the formation pathways of binary black holes, but also open a new avenue for detecting other hidden giants that may be lurking behind asymmetric black hole mergers. Since LIGO's first detection of gravitational waves in 2015, the observatory has recorded over 100 additional events, most of them resulting from black hole mergers. Each new discovery provides scientists with more data to unravel the mysteries of the universe's most extreme objects, which remain notoriously difficult to study. But this isn't just a scientific breakthrough, it's a gateway into a realm where black holes aren't merely devourers of light, but architects of complex cosmic systems. If this triple black hole system truly exists, then we're only beginning to scratch the surface of the universe's hidden stories. In the heart of endless darkness, where even light cannot escape, black holes are not just consumers of matter, they are sculptors of gravitational choreography that defies the laws of physics. The potential discovery of a hidden supermassive black hole behind the asymmetric GW190,814 merger has reshaped our understanding of cosmic architecture and revealed that even in the silence of space, intricate interactions are unfolding, ones we're only just beginning to perceive.